Hello everyone. Today we are going to learn how to construct a 110 slab for anatase structure. So this is the structure of anatase, and this is our current set of basis vectors a, b, and c. And we need to know, the first thing we need to know is that if we want to transform our current set of basis vectors to a new set of basis vectors, the relation between these two sets of basis vectors are here in the panel of unit cell transformation in Vesta. So I've already written this in the PowerPoint, and this is the relation here. And suppose we already know our current set of basis vectors, and suppose we already know a new set of basis vectors, then we can determine the P matrix, which is the rotation matrix here, right? And remember that A prime, B prime, C prime, and A, B, C here are all column vectors. So if we already know our old basis vectors and new basis vectors, then we can multiply the inverse of the matrix, the inverse of the old set of basis vectors, like this, multiply this term on both sides of this equation, and this is actually identity matrix. So we got this relation. So we can determine P matrix as this. So our job is to determine the old set of basis vectors and new. Sorry. This is our old set of basis vectors. This is our new set of basis vectors. So let us return back to this place, and where is our old set of basis vectors? That is our current set of basis vectors here. Because alpha, gamma, and beta are all 90 degree, so we only need to know these three values to construct our old set of basis vectors. We can copy it. Okay, this is our old basis vectors. Okay, this is our old basis vectors, and now we need to know the new set of basis vectors, a prime, b prime, and c prime. How to determine it? Okay, let us look at this structure. We want to cut a 110 slab, so first we need to determine where is 110 plan. And in this panel, in Vesta, we can plot a plan. Okay, this is the meter index for 110 plan. And by adjusting this value, we can place the plan at different positions. for example, right? So 1 is already enough for us. So this is the 110 plan for a structure of anatase. And now we need to determine the new set of basis vectors. That is to say, we want our A prime and B prime in new set of basis vectors is parallel to this plan, 110 plan. So how to do that? We can select this vector as our A prime vector. And how to calculate it? Okay, we can subtract the position vector of this atom from make a difference between the position vectors of these two atoms. So let us firstly look at the position vector of this atom, which is here. And we need to make a difference between the position vectors between these two atoms. So we also need to know the position vector of this atom. Okay, now we can obtain A prime. A prime here is actually this vector, right? So now we need to determine the B prime vector. How to determine that? We can set this as our origin point, and so to obtain the B prime, we can make a difference between the position vectors of these two atoms, right? So firstly, we need to know the position vector of this atom. Sorry, we need to we need to copy this and paste it here. Okay, this is the position vector of this atom, and this is the position vector of this atom, and we are going to make a difference to obtain the B prime vector. Okay, good. Now we need to determine the C prime. C prime need to be perpendicular. The ideal case is to be perpendicular to this plan, right? But it is not necessary. But the ideal case is to be parallel to be perpendicular to this plan. So we can directly select these two atoms and make a difference between the position vectors of these two atoms to find a C prime vector. And let us copy this. Sorry. Now we are handling with C prime. So we copied the position vector of this atom, and the position vector of this atom. Good. Now we already have this is old and this is new. And now if you look at our code here, there is some problems. What's the problem? Remember that in the information given in the panel, A prime, B prime, C prime, and ABC are all column vectors. However, what we are using now is row vectors. So we need to transpose basis old and basis new to get a true basis old and basis new. Sorry. Okay, now we already have basis old and basis new, and according to this relation, we can get P. And we can print P, rotation matrix P. Okay, this is our rotation matrix. We're going to apply this rotation matrix to this panel. -1, 01, 101, 0, -1, 0. Okay, we don't need a region shift, we just need a rotation matrix. Okay, good. Now we apply this rotation matrix. See? We have already successfully transformed the basis vectors to a new set of basis vectors, and now this plan, this 110 plan in original structure of anatase is actually parallel to our AB panel, right? This is A, this is B. So this surface is actually spanned by A and B vectors. So that is to say we already successfully construct a slab. Actually, it is not a slab now because we haven't added a vacuum space on it. So we need to add a vacuum space. We can firstly export this structure. Okay, slab. We're going to choose Cartesian coordinates to make it more convenient to adjust the supercell. So this is the structure we exported. Now we're going to adjust the values in it. Okay, we don't need to adjust the values for positions of atoms. We only just need to adjust the value here. Let us choose 20. And you can set any value you want. And let us save it. Now we can see what kind of structure we obtained. Okay, this is not that clear. Okay, we have already successfully constructed the slab, the 110 slab for structure of anatase, right? Thank you.